Time for us to get started on part 2. Thanks for returning. Did any of you not come to part 1 of this? One of you? Okay, well, you're going to be completely lost. Sorry about that. You can go back and watch it later, though. The recording may make some sense. No, I don't think so. I'm going to hopefully cover this from a perspective that, anybody that didn't go to part 1 will still get something out of this. But I would encourage you to go back and watch part 1, after when it's recorded and online again. So I'm Greg Kazanza. Most of you already know that since you came to part 1. I'm going to be talking about more networking with VMM. I've got Charlie Wen from the core networking team in Windows. He's going to go into some great detail about how the network virtualization gateway is implemented in Windows. So he's got some really good information, and if you have some really hard technical questions for him after the session, I encourage you to go ask them, and he'll be happy to answer. So what are we doing in part 2? In part 1, we learned all about how do you set up VMM networking starting from scratch. I showed you how to create logical networks to model your physical network using traditional VLAN technology, essentially. You're still going to use traditional VLAN technology for modeling your network with network virtualization. But with network virtualization, you're going to get the added ability to layer essentially new tenant networks on top of that. And that's what we're going to be talking about here in this session. So the whole focus on this session is about how do you take your basic fabric infrastructure and then add network virtualization into that to get those benefits out of it. And I'm going to be talking really from the perspective of what we did in the R2 release, because we introduced the technology in Windows Server 2012 and VMM 2012 SP1 in a really basic form. But it's really in R2 that we took a look at what's needed for hybrid networking end-to-end as a solution and figured out where are our gaps and what do we need to do to complete the story and really make it work for all of you. So I'm going to be talking about that from that perspective of hybrid networking as a scenario throughout this. We looked at it from the perspective of not just VMM and what does VMM need to do to make this a fully fledged scenario, but also Windows Server. And the core networking team were deeply involved in R2 and working together with us. And then all the way up, we have a team in India that does additional networking capabilities. They do the routing remote access server. We work with them. We work with the Azure team to make sure that the portal that they built in the Windows Azure Pack expose this functionality end to end. So there are a lot of teams that work together to bring what you're going to see now to all of you. So, before we get started, I want to kind of level set so that we all know what I'm talking about when I talk about a hybrid network. What do I mean by that? When you look at a physical data center, whether you're a hoster or an enterprise, you have a number of physical resources: your compute, your storage, and your networking. You're hopefully managing it with VMM, and that's all connected to your outside world through the internet. And what you do as a hoster, or as an enterprise as a hoster, IT as a hoster, is you essentially carve up these physical resources into individual tenant resources. So you give your wingtip tenant their own essential view as if they had their own private data center. They get their own amount of storage, their own amount of compute, and even their own amount of network. And they have this illusion that it's all theirs, and they have no idea that there are these other tenants there as well. So tenant 2 gets their own view of the network, their own storage and compute. Tenant 3 gets their own. And then once you have your own isolated environment, you can then deploy whatever services you want. You don't have to worry about those services being seen by other tenants. You don't have to worry about them colliding with other tenants. And you have your own private island to work with. That's great for compute and storage, to have this virtualized view of the data center. But for a network, to really utilize that network, you need to have a connection to the outside world. And so when you have these virtualized networks in these tenant environments, you need to have something that connects you to the outside world. And that's where there's the role of a gateway that plays this connection. So that connection is what bridges your virtualized environment out to the rest of your physical network. So you can actually then get into these isolated resources that you have at a hoster and use them as if they're part of your own data center. So when you have this gateway in place, then you have the ability then to extend what you have hosted at one location and connect it through a site-to-site tunnel to another location. You want to be able to bridge it through a site-to-site VPN so that whatever you have in your hoster or your other site, if you're an enterprise, you can connect seamlessly through a VPN tunnel. You can use the same portions of the same address space at each site. So you can use your enterprise address space, just put different subnets at each site, and they can talk to each other as if they're one network. So that's really what you want out of a hybrid network. Regardless of where it is, you want it to appear as if it's one network. At the same time, these hosted resources sometimes need to access other services out on the internet as well, not just at your on-premise data center. And you don't want them to have to hop through your VPN tunnel to get back out on the internet. So you also want to have the ability for a hosted network to be able to talk directly out to the internet. In order to do that, because all of these hosted networks could be using the same address space and non-internet routable addresses, you need to have a way to do NAT in order for these machines and these hosted networks to be able to get out and talk to these service providers, whether it's Windows Update or some other service out there. So these are kind of some of the goals of what we want to be able to accomplish with a hybrid network. Be able to have seamless connectivity to on-premise, not just to one site, but to multiple sites, and then give you the ability to talk out onto the internet and choose which of those settings you want. So as we looked at this, how we wanted to enable this hybrid networking scenario, the components that we really needed to focus on in the R2 release were VMM, because VMM has to manage the whole process. We wanted to make sure that it could manage it end to end. We need a gateway to bridge these virtual networks with the outside world. How many of you wanted to use a network virtualization with Windows Server 2012 and VMM 2012 SP1, but couldn't because there was no gateway available? Right? See, a lot of you, we know that was a huge gap. And we'll talk a little bit about that and what we can do for even you today with SP1, with the partner solutions we're working with. Then we also want to make sure that as this gets exposed to the end self-service users, the people actually creating the VMs and the workloads, that they could do it through a self-service portal and actually create their own networks and establish their own connections between the sites. So the Windows Azure Pack, what used to be called the Windows Azure Services for Windows Server, was really our portal for doing that. So we took a look at that as well and made sure that that had all the capabilities needed to create these hybrid networks. So if we look at what we had as a starting point in 2012 in SP1, we had the basics of network virtualization. We have routing remote access server role that gives us the ability to create site-to-site VPN tunnels. We have Microsoft IPAM lets you manage your address space. I talked about that a little bit in my first session, kind of as the core of what's available in Windows Server to use as a building block. In VMM 2012 SP1, we introduced the ability to create one of these VM networks that with its own address space using network virtualization and be able to manage that and actually create a single VPN if you had a gateway in place to be able to connect to the outside world. So very limited connectivity, but it was there, and we had the foundation. And we relied entirely on third-party gateways, of which they're starting to come to market now. We see the third-party gateway as a necessity that will continue to live on, even as we bring our own software-based gateway, make it available as really low-cost entry point into network virtualization. We think at some point there will be a scale at which you'll need to go to a hardware-based gateway. These partners will be able to innovate and provide additional functionality that our own inbox gateway doesn't do. So there's always going to be a role for third-party gateways. But you can see we have gateways now available from F5. Iron Networks is shipping devices. And even Huawei will be shipping a gateway this year as well. And each one of them brings their own unique experience to the gateway space. F5 uses Hyper-V today as doing the encapsulation decapsulation, but then they use the big IP inside, and I'm going to show this to you in a minute, to actually do the routing capabilities, so they can bring multi-tenancy into their VMs. Huawei is an entirely non-Windows-based solution, and Iron Networks is an entirely Windows-based solution. So everybody's bringing their own unique capabilities to it. Iron Networks has said that their device that they're shipping today, their hardware appliance that is Windows-based, will be upgradable to R2. So if you get a gateway today from one of these third parties, they're all looking at their upgrade and migration capabilities to bring you into R2 and take advantage of the new capabilities of R2 as well. So for those of you that are in production today, you do have options available. And F5, actually, if you go talk to F5, they'll give you evals of their current gateway solution they have today. So if you actually want to just try it out, talk to them about that. Let's actually see what it looks like, though, if I jump over into my F5 environment, which I have right here. So this is a 2012 SP1 VMM server that I have set up here. And if you actually go and look at what we have in the fabric, we actually have a gateway added. This gateway is an F5 big IP NVGRE gateway. This is their, essentially they have a provider that gets installed into VMM. It goes and configures Windows to set all the necessary network virtualization policy through WMI, and then it also talks to their big IP in order to configure it for the tenant configuration as well. Once you have that installed, then you can add the big IP and that host into VMM, and then you can actually create VM networks that use network virtualization and have an actual gateway involved. So if I look at this VM network here, go to the properties, you can see that it's configured to do routing onto another local network. So this is basically going to take traffic from a this virtual network and just route it then onto a physical network as if it were a regular old network. And that's what's going to bridge the network virtualized world into the physical world. So I can actually go and look at a VM that's actually connected to this network. I have a couple of VMs here on this cluster. Go to my marketing 1 VM, go to the properties. You can see that we are connected to that network right here. So this is the VMN Contoso marketing network. And if I actually open up that VM, connect to it, and then open up Internet Explorer, you can see that we get access to Bing just like we were, using a regular physical network, but it's actually using network virtualization. So it actually behaves just like a regular network once you have a gateway in place. So this is the F5 big IP based gateway. So you can talk to F5 and get an eval of that if you're interested in trying it out. And you can use that today with SP1 that's shipping in Windows Server 2012. So the other thing we introduced to work with 2012 SP1 was the Windows Azure Services for Windows Server. That was our first example of using the Azure portal essentially as a front end for tenants to be able to interact with Windows Server and be able to have tenant self-service using the Azure experience. And we had the basics of being able to create these virtual networks through that portal, but they weren't hybrid networks because you could not configure the actual external connectivity. They were completely isolated, great for doing tests, isolated tests, lab environments, but really not good for actually creating a hybrid network. So we knew there was a lot of work we had to do there, but we had the starting point laid out already. So we looked at what were the benefits that we wanted to get out of all of this work that we did as a scenario to bring hybrid networking to all of you. We wanted to make sure that, number one, it's cost effective, that you don't have to spin up a VM for each tenant that you want to have in your environment. We want to be able to make sure that you use your resources efficiently. We want to make sure that it's reliable. We want to make sure that you don't have really any noticeable downtime. So we built in clustering. We want to build clustering into the solution. We wanted to work seamlessly to utilize network virtualization and make sure we had self-service provisioning. So that's what the hoster or the person building the private cloud, we want to make sure they had those abilities. For the enterprise, we want to make sure they could basically establish the connectivity they needed in order to have reliable connections to multiple sites, get access to service providers on the internet, and basically be able to configure it easily using an experience that they may be already familiar with from Windows Azure. So these are kind of some of the goals we wanted to go after as we approach this. So what were some of the things that we needed to do working together across Microsoft, all the different teams that we have that are playing a part in all of this? We worked very closely together to try and get this right. We looked at Windows Server, and we decided that we needed to have a multi-tenant gateway. This basically means that you can have a single VM that can host dozens, perhaps even eventually 100 or more tenants on a single gateway without having to spin up a new VM to achieve that scale. We wanted to make sure we could do site-to-site VPNs. We already had the basic of that, but we wanted to make sure that that capability was available in the multi-tenant gateway. We wanted to introduce NAT into the gateway as well, so we could get this direct internet access, both outbound and inbound, being able to access directly into your network. And we wanted to make sure that you could manage your fabric space with IPAM, and we could actually exchange your fabric address spaces with IPAM as part of the solution. Then we looked at how System Center had to manage it. We wanted to make sure that we can, through VMM, deploy the gateway, configure the hosts in a way that's needed to work as a gateway, and do all of that without ever having to go to the host itself or the VM itself. We wanted to make sure that we had integration with IPAM and top-of-rack switches so you could manage your fabric easily. We want to report metrics. We made sure that we could report metrics for the usage of these networks into our chargeback system so that if you are a hoster or an enterprise, you can see how much these networks are being utilized so that you could bill appropriately. And we need to make sure that this was exposed through the SPF layer, Service Provider Foundation, so that our own Windows Azure Pack could build the portal on top. Or if you want to build your own portal, you could utilize all of these capabilities through your own portal, your own whatever infrastructure you want to build on top of it. And then Windows Azure Services for Windows Server, which is now the Windows Azure Pack. Basically, we need to make sure that a tenant could come into the portal, create their own network, and configure it in the way that they need it configured to establish all of these multiple endpoints and NAT, you name it. So what we're going to walk through now is basically the scenario of how are you going to configure and deploy all of this using VMM and Windows Server. We're going to start with how are you going to configure your fabric to enable network virtualization in the fabric, to prepare it for being able to deploy the gateway. So that'll be the next step, is then how do you actually get a gateway into your environment, get it ready to use, and get it up and running. And then finally, what's the tenant experience look like for the people that are actually going to be using these networks in your environment. So we're going to start with the basic diagram that we built and the basic infrastructure that we built in the first session, right? Where we have a corporate network, we have a public internet that the tenants are going to need to get access to, a management network where all your own resources talk to each other. And basically, these tenant networks are going to be virtual networks that live on top of a physical provider network. The physical provider network is what actually routes the packets onto the wire, encapsulated form of the tenant packet. And these are all going to go out to the public internet through the network virtualization gateway. So in order to configure the fabric, the basic steps that we're going to do is, number one, we need to enable network virtualization. Now, previously, if you're using Windows Server 2012, there was a filter you had to enable on the host to make sure that the network virtualization filter could process the packets. You don't have to do that in 2012 R2 anymore since the virtualization filter moved into the virtual switch itself. It's just always available now. You then need to configure your address space for your provider network. So that was the network here, this kind of orange-colored network. You need to define an address space for that. So we have to be able to allocate static IP addresses to the host to use to send the packets on the wire. And we have to basically say that this network is used for network virtualization so that we'll know then when a tenant comes in to create it which network to use. And then one thing that I want to mention is to make sure that if you can use a mixed environment of 2012 and 2012 R2 Windows Server hosts, but your 2012 hosts need to have this KB here installed on them. Otherwise, they won't be able to communicate with the R2 hosts. There was a slight packet format issue in 2012 that was fixed with this KB. So once you have that KB installed on your 2012 host, then they can actually work with your R2 hosts as well. One thing to keep in mind, though, is that the gateway, using the new server gateway role, has to be a 2012 R2 host and a 2012 R2 VM for the gateway. All right, so let's go and enable this on the fabric. Switch over. All right, so we're back to the VMM server that we did the initial configuration on. We have the two hosts that we've already set up. And so the first thing that I'm going to do is I'm going to mark one of these hosts as being my gateway host. We have to do this because the network virtualization policy, so all of the information that the host uses to enable network virtualization, normally comes from the VMM server to the VMM agent that's out on the host. When you're using a host as a gateway, that policy actually comes through a different path. It actually comes through a plugin model so that we can talk to the Windows Server gateway in the same way that we would talk to a third-party gateway. But by doing that now, the host policy no longer applies, and so we have to tell VMM that this host is dedicated to a gateway because of that policy is going for the gateway. We do that in the preview through PowerShell. We're adding a checkbox to the host properties for RTM, but it's very easy to do through PowerShell, so I'm going to bring that up right now. Probably should have actually used the window that I already had open. I'll use this one. Oh, actually that one's coming up now. So I'm going to get the host that I want to use as the gateway. I'm going to use HVH03. Oops. Equals get scvm host. And let me zoom in on that so you can see it. HVH03. So I got the host, and I'm just going to do a set scvm host, VM host, $H, and there's a new flag on the set called is dedicated to WNV gateway, and you set that to true. And this will basically tell VMM, don't place normal VMs on here, this is only for gateways. Okay, so that now succeeded, so now this is dedicated to being gateway. Whoops. Wrong button, there we go. Okay, well, we don't need help right now, not yet at least. Okay. So we marked it as a gateway. Now, next step is we need to actually define our provider network so that it's available for use for hosts, so we can allocate addresses for use for network virtualization. So I do that by going to my logical networks view, and I'm going to do this in much the same way as I did for my internet and management networks. I'm going to create a logical network. I'm going to call this my HNV for Hyper-V network virtualization. It's going to be one connected network, and I'm going to check this box that says allow new VM networks on here to use network virtualization. And then I have to give it, specify which VLAN I want to use. And this is going to use VLAN 105. Actually, I believe it's 106. Double check that. Oh, it's actually 104. There we go. And I can define whatever subnet I want on that. These packets actually never get routed outside my data center. So I can actually use an address space that's completely separate from even my corporate space, from my management network. And they never need to get routed outside your environment, because that's what the role of the gateway is for. All right, so these are my provider network. I have my subnet defined. And then I have to create an IP pool. An IP pool. This is my provider pool. H&V network. I'm going to use all the addresses in the range. If I have multiple subnets, I need to have a gateway so that I can route these packets between them. So it's 1.1. Don't really need DNS because network virtualization is just going to send via IP address, so I don't need a DNS server on this network. And then I'm going to finish that. So now I have an IP pool. I have a logical network defined, an IP pool. The last thing I need to do now is actually associate it to the host, so I know which adapters on which host this network is available on. I have to make sure, of course, that this VLAN 104 is actually enabled on the ports for that host. But I know that I have it enabled on all the hosts, so I'm not going to do that. The way I make it available is by I go to the port profile that I just created earlier, and I'm just going to add it to my trunk port. This is really one of the nice things about using the logical switch, is that I have a single place that I can now enable this new logical network that I created. I don't have to go to every host individually. I just enable it on the port profile. If you do have 2012 hosts, then you will need to check this box off. This box will enable network virtualization filter for 2012 hosts. For R2, then this box is ignored. So there we go. We've now enabled network virtualization. We've created a provider address space, and it's just about ready to use. All right, so let's switch back to the slides. So we've configured our fabric. The next thing will be how do you actually get your gateway up and running, right? Because now you've enabled network virtualization. I could actually start creating VM networks now on this fabric. deploy VMs to these two hosts. Those VMs on the same VM network would be able to talk to each other, but they don't have a gateway, so they can't talk outside of their virtualized network. So we need to enable that by deploying a gateway, getting it up and running. We're going to see a role for third-party gateways to continue, either for scale or for functionality that isn't inbox in Windows. And then we're going to have the Windows Server Gateway, which really we see as a great entry point into network virtualization world. Every single one of you with Windows Server is going to be able to get a network virtualization network up and running with Windows Server. So here to talk about that Windows Server Gateway in great detail is Charlie from the Windows Core Networking team. I'll be back after Charlie's done to actually show you how to deploy it through VMM and finish up the configuration.
Thanks, Greg. All right, I'm from Core Networking team, and I'm going to talk about what we did in the platform to enable the scenarios and the deployment Greg just talked about. So I think I'll start with 2012. Still pretty fresh. We just released less than a year ago. So we introduced Hyper-V network virtualization in this release and really make it possible for service provider, enterprise to virtualize its physical fabric so their customers can bring their own IP address, topology, and if the customer has a remote site, and they can use the site-to-site VPN capability to connect the two networks together. Now, there's a lot of room for improvement, of course. We worked with a lot of partners and customers and get their feedback, including Azure. We worked with Azure very closely. And the lessons we learned, actually, I think Greg already mentioned some of them, is with 2012, when you have a tenant, you have to spin off, you have to dedicate a VM for a specific tenant. Consider if you have like 1,000 tenants and you have to have 1,000 VMs. We only provided limited routing support in Server 2012. Actually, to be frank, you have to do the static routes configuration. When it comes to the security policy configuration, let's say you have the site-to-site configuration, you have to go through step-by-step manual configuration. It's very tedious, as we learned from customer. And of course, we don't have a data center scale NAT in Windows Server 2012. So it's not efficient. It's not the most optimistic deployment for many customers. So that's the lessons we learned, and that's the areas we actually try to invest and improve in 2012. So Greg mentioned that we actually implement this multi-tenant gateway. And it's really a big deal. And just think about it. I mentioned 1,000 customers, 1,000 tenants. You don't have to, with R2, you don't have to spin off these 1,000 VMs. You can consolidate these tenants on, let's say, 10 VMs. And that's a significant saving. Now, our gateway is in the data path in your hybrid cloud, between connecting the two networks. So high availability is really critical. And to provide this high availability, and we support clustering for the gateway. And I'll talk more about it. Greg actually mentioned we try to make management easy, and we did a lot of work in service CVMM to hide some of the concepts, makes really configuration and management easy. But we also try to do something in the platform to make the configuration easy. And the one thing we did is we support something, a routing protocol called BGP. If you're actually familiar with networking, you should know this is a very common control protocol supported by a lot of vendors. And last but not least, we support a multi-tenant NAT. And so you have these virtual VM networks, and these VM networks can connect to the internet directly and support a whole new set of scenarios. So with that, I think I'll do a demo before deep dive. So that basically gives you some idea So let me bring my, actually I have one slide to show. So this is the slide. So we always get the feedback. The networking demo is not always is not the easiest thing to follow. So I think I come up with this slide just to walk through the demo we are doing. So essentially, you are seeing is a two-node cluster. It's actually have this our inbox gateway. So what we are going to do is we're actually going to have we deploy this on HMV network, and you will see actually have two tenants, and each of these tenants has a web server, and they will have the same IP address. That's actually what HMV enables. And then I'm going to just have a client. The client, just imagine this client is outside the data center. And the client actually is going to connect to the web server through a NAT configured on this gateway. And I'm going to download files. And when the file is being downloaded, I'm going to we're going to switch over, fail over the gateway, and you will see actually the file download actually continues. That kind of shows the fail over and high availability. So this is a live demo. Hopefully it works. Oh, I haven't switched over yet. Let me switch over. Okay, so just quickly, and you can see I have 4 machines, just what you saw in the slide before. And have a gateway, and let me quickly log in. All right. So here I want to show you just run a few PowerShell commands. And the first thing you will run, it will actually run a few already. You can see it's a two-node cluster, and it shows this one actually is the owner, right? The Cloud Gateway 2 is the owner. Now the command I want to run is this one. Get new NAT compartment. It's a new command we actually introduced in R2. And once you run it, it shows you actually have multiple compartments, and 2 actually are for the tenants, and the 1 is actually for the default compartment, which I will talk about. The 2 so each tenant have its own isolated container. Just think about that. So just quickly, I go to the web servers I talk about. So this is the web server host, and I have these 2 tenant web servers. And you can see they have the same IP address, 10.0.1.101. Right? You can see, and it's an internal IP address. So now I'm going to go back to the client. And this is the client that is outside the gateway, outside the data center. So I'm going to just open the web page, and so I have these 2 tenants, and open the website. Each tenant just open the web browser and log on to the web server. And you can see they log in using the public IP address. So each of these tenants has its own public IP address for the web server. So we actually log in using the public IP address. Right. So I'm going to just download a file. I don't need to do 2. Okay, let it run. So the file copy just started. Now I go back to the gateway, and I just do a quick failover. This is the command we do the failover, and also measure how much time the command takes, and takes less than 2 seconds. And then we move back to the client, and you can see the file download just continues, and you can see the progress, and it continues. Basically, from the client's point of view, the failover just happens transparently, and that's how we provide the HA, high availability. Just to show the gateway really just fails over, we move on to just do a quick checkup. And this is the new gateway, the new active node. And you can see here, If I run the same command, and you can see Cloud Gateway 1 now is the new owner of this cluster, this 2-node cluster. So this is basically the demo. Okay, let me switch over. Okay. All right. So far, we spend a lot of time talking about hybrid cloud. And we understand many of you are service providers, but we also understand many of you actually are enterprise. You actually have your own private cloud. So you're thinking about HMV because we talked a lot about its benefits, and you're thinking to adopt it. So I just want to briefly talk about how our inbox gateway fit in this private cloud. So just imagine you are enterprise. You have some business units. Let's say engineering team. They have this need. The need is the engineers need to constantly make configuration change, have their own topology, spin off new VMs. Now in the past, these engineers have to open TechEd, right? And the support guy has to answer the ticket and do the deployment configuration. Now with HMV, and we abstract this, you can create this VM network for each of the engineer and each of the business unit. They no longer have to depend on the infrastructure, the IT infrastructure, and you have this independent virtual network or VM network. So this is good. That's exactly what HMV is designed for. But in the meanwhile, you as enterprise still have a lot of services running in your physical infrastructure, right? Say you have ADS, Active Directory, you have a DNS, you may have your SharePoint, web servers running on the physical infrastructure, right? You are not ready to virtualize this infrastructure because probably there's no need for that. So how do you provide the connectivity between this HMV network to the existing infrastructure? So that's a challenge. And we solve this challenge, we meet this challenge by this inbox gateway. And we are basically called simple, this gateway just provides a simple forwarding capability between your existing infrastructure and the HMV. Now you say, how about hybrid? I mean, I want more, I want both. Actually, it works perfectly for both scenarios. In this case, actually, I imagine you are enterprise, you actually use some third-party existing solution to connect your one private cloud to a remote site. You have this third-party solution. So what we are saying is, it's perfectly fine to actually have this forwarding gateway so that the remote traffic will come into this site-to-site VPN tunnel, going through this third-party router, and go through this forwarding gateway and to reach the HMV network. So we really put all things together, and so you can enable it in your data center. So that's actually we try to make sure to remove as many deployment hurdles as many as possible. So these are pretty much the high-level description, a high-level introduction of the changes we made in the platform. So now I'm going to dive a little bit deep, hopefully not too deep, to talk about exactly the change that we made in the platform. So the first thing I'm going to talk about is the multi-tenant networking stack. So what you are seeing here is just 2012 machine, and it has a TCP/IP stack and has a network services on it's just bound on top of the TCP/IP stack. It runs in a VM. So what we implemented in R2 is we introduced a new concept called compartment, and you saw that in my demo. And this compartment essentially is just a container. You can think about the container. And we created this compartment, one for each tenant network. And inside this compartment, you can actually create IP interface. You can create IP interface, depends on your deployment requirements. And you can configure IP address on this interface and configure IP routes on the interface. And because this compartment is really isolated from each other, right? That's how we actually achieve, make sure that you can deploy multiple tenants on a single VM while providing, supporting overlapped IP addresses. Right? Each tenant could bring its own IP address, and we use this isolation compartment to isolate this configuration. You can also see the default compartment. So the reason we have this default compartment is because we have these multiple compartments now. Essentially, we actually, in the past, we only have one single class of a network service. Now we actually have two. So we have the existing network service, and we have the so-called multi-tenant network services. So the existing network service, like the Windows existing ones, DNS, for example, will work with talk to the default compartment. But the new network services, and I will talk about them, like the site-to-site VPN, will actually be able to talk to each of these tenant compartment. So this is a new class of network services. So I think I talked about it. The compartment provides the isolation, and that's how we support overlapped IP addresses. And one thing I think I want to mention is this is supported, the multi-tenant stack is configured in the Hyper-V switch. So basically, when you onboard VM, you configure the Hyper-V switch, and you specify whether you want to make that VM multi-tenant aware or not. But of course, this is actually, if we use SCVMM, these details actually is taken care of by SCVMM. But I want to give you some insight in what we do in the platform. All right. So remember, I talked about the multi-tenant service, right? These are the new services that we introduced. So I'm going to talk about two of them. One is actually the multi-tenant site-to-site. So let's just walk through how it works. So let's say you have a tenant, North Wing in this example. You onboard as a hoster, you onboard this tenant, and you create a corresponding compartment for this tenant. And let's say you want to provide the service, site-to-site service this tenant has a remote site, you want to provide site-to-site VPN service. What do is you create an interface in that compartment. It's a site-to-site interface. And then the remote site starts to connect to this gateway. Now, before the connect gets established, the connection will send information such as the security profile. And we support multiple ways to authenticate this connection. You can either do this pre-shared key, or you can do the machine profile credential, or you can do EAP. So we support multiple ways. So once the remote connection is identified, is authenticated, we will actually connect this. We can map this connection to the right compartment based on the information. So similarly, let's say you onboard a second tenant, and what we do is essentially we just repeat the process. And in this case, Contoso has two remote sites, so you actually create two VPN interfaces in that compartment. So now, so the question you may have is, what happens because we have two interfaces? How the routing happens? Well, the routing happens from the Contoso's VM network. The traffic will always send to the gateway, right? Because we have the policy say any traffic goes beyond the data center to the remote site will go to the gateway. So the traffic will come to the gateway. And remember I mentioned that we have this interface and IP address and the routes for this tenant in his own compartment. Routing will happen in Contoso's compartment. Right? Routing will happen there, and we'll decide which IP interface the packet will take. So I want to also mention, because we support this multi-tenant gateway, one question customers ask us is how do we provide some SLA? Because what if actually a tenant uses a lot of a resource? how do we prevent things like starvation. So one thing we support is the rate limiting. You can actually configure rate limiting in either direction on each of these side-to-side tunnel. So that's, you can, VMM also, SCVM actually provide this configuration. Okay, so the second multi-tenant service I'm going to talk about is NAT. So again, I'm going to use the two tenants example. You have Northwind and Contoso. So what do you do is, let's say the Contoso VM network has some workload that has a requirement to connect to the internet. What do you do is actually you need to do is you create a Contoso NAT, right? So the packet will send, again, the packet is going to the internet. You will go to the gateway, and the gateway, and it will, in the compartment, it will basically will say, this is to the internet, and I need to go to send the packet to the default compartment because that's where the NAT is configured. And when the packet reaches the compartment, we'll do the packet translation, which is typical NAT function, and then we send the packet to the internet. So that's how the packet flows. And we can do the same for another tenant. Now, what happens, imagine a different scenario. The scenario is you have the tenant actually has some workload, let's say web server, hosted on this virtual VM network. How do you actually provide connection from the internet to the web servers? So what do you do is, again, you actually configure something called a static mapping, which via SVMM allows you to configure. So when the packet comes in and comes to the NAT, and the NAT will find the static mapping and to decide which tenant this packet should be sent to. And we're sent to Contoso in this example. So the packet reached the Contoso compartment, and remember, the routing actually happens there, and the gateway will send the packet to the web server hosted on this VM network. So that's actually how the packet works for NAT. So next, I'm going to talk about BGP, just give you a high-level overview of BGP. So BGP is a control protocol, and we try to use BGP to make the routing management easier. So in this example, imagine you have a Contoso, kind of back to the previous example. You have a Contoso, you have two sites, and you have a hosted site. So you configure this side-to-side VPN between each of the two sites. You use the BGP to exchange the information, the routing information between them. And the BGP will select the routes for the traffic between each site. So now imagine something happened. There's a connection just breaks between site 1 and the hosted site. Now, because of in the past, remember with the static mapping, the admin on both sides has to be notified first, right? Sometimes that takes hours, sometimes even longer, and then go log on to the servers on each side and do static mapping. But with BGP, these things, the control protocol always runs, right? And actually can detect the failure almost instantaneously. And because it can detect the connection issue, it will select the best route because of that breakage. And because of that, the traffic between site 1 and the hosted cloud will actually now go through site 2. All this actually happens automatically, right? So this is BGP. Just a quick recap. All the tenants, because this is a multi-tenant gateway, so all the tenants can establish a BGP session and to the gateway, and we support overlapped BGP IP address tables. Okay, so the last thing is actually I mentioned the guest clustering. We use guest clustering to provide HA. So just quick overview. This is the gateway will be deployed on a 2-node cluster. So one node will be active, and the other is always standby. the connections, all the connections, side-to-side tunnels will actually always go to the active node. And the end-to-end connection just go through the gateway. Now, because we actually run the services, the clustering service inside the gateway, so any failure, like the service, the side-to-side failure or NAT failure, can be detected very, very quickly. And because we are able to detect the failure very quickly, we are able to fail over very quickly. And because of that, the end-to-end connection really can stay alive, and as you can see in the demo. So just a quick recap. So I basically talk about the inbox gateway and how we actually support, what functions we actually provide in the platform. And the idea is, the goal is really to provide a highly scalable, redundant, and easy to manage software gateway. We provide the scalability through this multi-tenancy, multi-tenant networking stack. We provide this high availability through the clustering, and we make it easy to manage through the VMM work, and also make the change in the platform, like supporting the routing control protocol, like BGP. So that's the pretty conclude my part. And if you have any questions, just feel free to come up and let me know.
Thanks, Charlie. All right, so now you probably want to know, how can you actually deploy that and get it set up from VMM? So, oops, let me just get back to my environment. Okay, back to VMM. So the basic provisioning process. Now, as I mentioned before Charlie came up, that we wanted to make sure that everything is provisionable through VMM, that you'll never have to go to the Hyper-V host itself or even the VM to actually do this configuration. That's true for deployment, for configuration, for the overall day-to-day use. There may be a time if you need to do some troubleshooting where you need to go in the VM, but really that's the only time that we would expect you would need to go into the actual gateway VM itself. The basic steps that you're going to go through, you deploy your host just like you would any other Hyper-V host. You can use VMM's bare metal